Hello students, and welcome to this continuation of our lesson on solving square root equations. Alright, so in our last video we saw two different ways to solve square root equations, and they're both pretty useful, and what I want to do is delve into some more examples here. So let's take a look. So we've got our problem here, and it's 3 plus the square root of 2x minus 3 is equal to 8. Alright, and I just want to solve this. I want to solve for x. So we're going to follow our SADMAP rules. So we want to get rid of the first thing on the outside first. So we look, there's no subtraction, but there is some addition. So I can subtract 3 from both sides, and you get square root of 2x minus 3 is equal to 5. Alright, now we're down to our square root again. And to get rid of our square root, remember, we have to square both sides. So the inverse operation, the opposite of a square root, is to square something, right? If I said 2 squared, that's going to be 4. And then the square root of 4 is 2. So I went from 2 to 4, and then from 4 back to 2. So it's kind of this circular argument here. Alright, so back to what we were doing. So to get rid of the square root, we have to square both sides, and we end up with 2x minus 3 is equal to 25. And so we get 2x, sorry, let me be more precise here. Then we see that we have a plus 3 down here. So we're now going to have to add 3 to both sides. So you get 2x is equal to 28. And then x is equal to 14. Alright, and then now let's just verify that this will actually work for our situation here. So we have 3 plus the square root of 2. We're going to plug in 14 for x. Alright, so now when we're checking, we have to follow PEMDAS, right? Because now we're evaluating. So we have to do what's in the parentheses first, so there's the 14. Then we need to do what's underneath the exponent first, so we get 3 plus the square root of 2 times 14 is 28, minus 3 is equal to 8. And then we say 28 minus 3, that's going to be 25. So this is the square root of 25. And then 3 plus the square root of 25 is equal to 8, but the square root of 25 is just 5. So you have 3 plus 5 is equal to 8. And we see that this is true, so we are happy. Now, both times that we've had to check for a solution and make sure that it's okay, there wasn't any problem, right? And that's because what we were doing earlier were a little bit simpler problems. So in example 4, we're going to see something called an extraneous solution. And an extraneous solution is going to be a solution which occurs algebraically but does not fulfill the expression. Alright, so why is it that this occurs? Well, what's really happening is that we're finding a solution that does occur, but it occurs outside of our range or domain. So you know how we've got our function and it typically looks something like this? An extraneous solution is just one which occurs on maybe somewhere outside of our range or domain. Alright, so let's see exactly what this looks like and how we can make sure that we're using the right solution and not the extraneous solution. So to get started, we'll just solve the problem. So remember, we're just following our SADMAP rules. We're trying to solve for x. So it's kind of difficult here to see what we need to do. But what you'll find is that whenever you have an x on the outside here, it's going to need to be left alone for now. So really your goal is to completely get rid of this radical, right? So you want to get rid of this radical here, and to do so you're going to have to square both sides. So before we can square both sides, we have to get the radical by itself. So our target here is going to be this 5. So we're going to add 5 to both sides. So now we've got the square root of x plus 7 is equal to x plus 5. And now, at this point, I want to square both sides to get rid of that radical. I'm not really sure how to work with it most of the time, so I'm going to try and get rid of it as soon as possible. So now I have x plus 7 is equal to x plus 5 squared. And this is where it's important to remember that if I have a plus b squared, this is going to become a squared plus 2 times a times b plus b squared. Or in this case, since it's x plus 5, this will become x squared plus 10x plus 25. And we can prove this by just doing our quick square, right? So x plus 5 squared is going to be x and then 5 and x and 5, and we get x squared here, we get 5x here, we get 5x here, and we get 25 here. And so this will give you this exact same expression. This is just a little bit of a shortcut. Alright, so we have x plus 7 is equal to x squared plus 10x plus 25. Alright, well now this right here is a quadratic equation, or a quadratic system. So we actually know how to solve this as well, right? We have to get one side equal to 0, and then we find the roots. So let's go ahead and do that. So we need to subtract 7 from both sides. And what you end up getting sorry, one second, I'm just making sure that we're separating everything. Alright, what you end up getting is that you get x is equal to x squared plus 10x and then 25 minus 7. So this is going to be 18. And then you subtract x from both sides, and you get 0 is equal to x squared plus 9x plus 18. Alright, and this is excellent for us right now, because now I'm looking for two numbers, right, which will add to make 9 and multiply to make 18. Okay, so two numbers that add to make 9 and multiply to make 18. And so what we can do here is you can do this in a couple of different ways. You can use your x, you can factor, you can use grouping here. Personally, I'm going to use grouping here. So I just thought of my two numbers, 3 and 6, and so I group it, and what ends up happening is I pull out an x, and then I have x plus 3, and then I also pull out a 6, so plus 6, and then that's x plus 3. And so my two factors are going to be x plus 6 and x plus 3. So I get 0 is equal to x plus 6 and x plus 3. And I'll get that x is equal to negative 6 or x is equal to negative 3. Alright, and then this is where the extraneous solutions come into play. So I'm going to go ahead and turn to the next page, but go ahead and continue doing this work below where we are at right now. Alright, and we're going to plug in now to see which of these solutions are actually correct. So we're going to take our original expression, which is going to be the square root of x plus 7 minus 5 is equal to x. And what I want to do is plug in each of these numbers to see if they're valid. So here we're going to plug in and we'll see. So for our first one, we'll plug in negative 6, and so we'll say that the square root of negative 6 plus 7 minus 5 is equal to negative 6. Alright, so let's see if this is valid. So negative 6 plus 7, that's going to be the square root of 1 minus 5 is equal to negative 6. And 1 is the square root of 1, so 1 minus 5 is equal to negative 6. And this will actually end up being negative 4. So negative 4 is not equal to negative 6. And so this is extraneous. So what I can do is I can come up here and I can cross out x is equal to negative 6, and I see that x is equal to negative 6 is extraneous. Alright, and then I'm going to do the same thing, but now for x is equal to negative 3. So I can go ahead and plug in here. So I've got the square root of negative 3 plus 7 minus 5 is equal to negative 3. Alright, so the square root of negative 3 plus 7, that becomes the square root of 4 minus 5 is equal to negative 3. And then this becomes 2 minus 5 is equal to negative 3. And we see that indeed 2 minus 5 is going to be negative 3, so negative 3 is equal to negative 3. So we are happy here, and x is equal to negative 3 is a valid solution. And just by the way, this was example 5. So this problem that we just finished, I'm sorry, it's example 4. So this is a continuation of, so end of example 4. And this also shows us what we need to do. So this extraneous solution, this is an x outside the radical and inside the radical. Alright, so let's move on to example 5, and this is going to be when we have an equation with two radicals. So if we have an equation with two radicals, what we want to do is we want to get a radical on each side. So we want to take this radical and move it to the other side. That way when we square both sides, our radicals both fall away. So let's see what that looks like. So we're going to add square root x to both sides, and you get 2x, the square root of 2x plus 1 is equal to the square root of x. And then you can square both sides. And what you get is 2x plus 1 is equal to x. And from here, you guys actually are pretty good at finding these types of solutions. So if we subtract, let's see, what do I want to do? I want to subtract x from both sides. So I get x plus 1 is equal to 0, and we get that x is equal to 1. Alright, excellent. Alright, and then our last example is going to be really hard, so I'm going to leave it for the next video. So have a wonderful day. Example 6 will have a video devoted to its own. Make sure that you guys write a reflection about this lesson, so go ahead and reflect on warm-up sheets. Make sure that you guys finish your homeworks and have a wonderful day. I'll see you on Monday.